So I love reactions. Full disclaimer, I love reactions. I love the study of kinetics. I did it for 6 years for a PhD. Really love this kind of information. That said, I know you just kind of gotten out of Chemistry 151, and so this can be a little daunting. So let's break it into smaller steps. Now, at the 151 level, you knew how to do this. I give you hydrogen, oxygen, and you go to water, and you can balance it. So you have 2 hydrogens plus 1 oxygen molecule goes to 2 water molecules. Well, now you're at the 152 level. And what we need to address is the fact that this isn't actually true. See, what we write typically up here is what's called the overall reaction. And the overall reaction says if I take reactants and they run a reaction, what do I ultimately end up with? But I'm going to gloss over details. In reality, almost no reaction runs as written. Typically, we have what are called mechanistic steps. So what a mechanistic step is an individual step along a reaction pathway from reactants to products. So what's a reaction pathway? Well, what we have is an overall mechanism. And the mechanism consists of a series of steps. It's like instructions in a lab manual. You have to go through each of these steps in order to get to the product. A mechanistic step is just one of those lines in the entry of the reaction mechanism. So if we have oxygen and hydrogen, we mix them together in a reactor, they don't actually do anything. The big reason is that oxygen's a pretty stable molecule. It's got a double bond to itself, pretty high energy bonds, so you have to supply some sort of energy to make them come apart. And so if we look at this reaction, our first mechanistic step to actually complete this reaction is we take O2 and we dissociate it into 2O. Now O, monatomic oxygen, is not a naturally occurring compound. We have to make it. It takes a lot of energy to make it. Typically we have to use a spark to make it happen. And so this is our first step in the mechanism. And what we produce is what's called a reaction intermediate. Now, a reaction intermediate is something that's formed along the way and then consumed by the time you get to the end. So we never actually see it in the overall mechanism. We don't actually isolate it in the final product, but it does occur. So it's kind of like cookie dough. When you make cookies, you have flour, you have eggs, you have milk. Those all appear on the counter. You make cookie dough and then you make cookies. But at the end of the day, the only thing you have is cookies. You don't have any cookie dough that's coming out of the oven. Now, big thing with our reaction intermediate is the first time we see it is as a product. We don't see it as a reactant. We have to create reaction intermediates before we can use them, which is going to be the second step here. We have hydrogen plus O goes to H2O. So for reaction intermediates, we start by making them, and we finish by consuming them along the pathway. Now, the rule with reaction mechanisms is we have to be able to add them back together in order to get our overall reaction. So we take this reaction, and then we double this reaction, and add them together. We get O2 gas plus 2H2 gas plus 2O gas, one of our reaction intermediates, goes to 2O gas plus 2H2O gas. And our 2 reactive intermediates are going to cancel out here. So when we look at a reaction, recognize that first of all, as written, the overall reaction is not a correct representation of what's going on. It's just the big picture view. If I put hydrogen and oxygen together in a reactor, I get water when I finish if this reaction proceeds. Now, it's going to proceed through a series of steps called the reaction mechanism. And each reaction mechanism is composed of reaction intermediate steps. We will produce, generally, what are called reaction intermediates. These are short-lived species. Sometimes we can isolate them, sometimes we can't. But ultimately, they're produced by one step and consumed by another to help us get the overall product.